All right. Let me teach you. Listen. First, some things about your quizzes is that I started grading first period specifically, and you guys were doing good, but that's as far as I got it. Like some of your class has been graded, but that's about it. But if you're curious, I think I graded most people. So if you're curious, I can show you it at the end of the class. It's just not in the grade book yet. That's one thing. Second thing is I had it. I just had it in my brain. But anyway, picture days tomorrow. Don't forget that. This is just me trying to make time to remember what I was going to say. I don't remember. All right. So then if I remember in the middle of the lesson, I'll tell you. But let us learn this advanced limit 1.4. So let me guess who is. Also, we gotta do these 1.3 ones. Remember? We forgot to do them. So let's do them now, and then we'll do 1.4, and then we'll be done. Also, if there's a day that you can't be talking over me, it's today because I'm recording this when people are walking out because I have a third period who's probably going to be pretty empty. So I'm recording the screen for people and well, I'm recording the whole class. So don't be talking over me. Learn from me. Learn. Good job, Laura. Good job. All right. It says evaluate this limit, and it's I mean it looks like that. I think most people in the homework got their questions out. So hopefully you guys see this, a lot of you, and are like, oh, this is no worries. I just have to do this thing. Do you guys remember what this thing is? Nice. Yeah, people were whispering conjugates. Yeah, that's what you got to do. But sometimes the conjugate is tricky to it's tricky to know what the conjugate is because look, there's a plus here and a minus here. Do I change both signs? Do I just change one? Which one do I change? Etc. That can be tricky, but the conjugate of a thing should just be the square root and then the opposite sign of the number. So what I mean is x squared plus 9 plus the 3. That's what you change, not the one inside the square root. Because you're trying, well, you can think about why that is, but you're trying to make the square roots exactly the same so that they'll cancel. If this was a minus, then you multiply them and you don't, nothing can. So anyway, there's that over the same thing. And then, okay, and then that's the trick. Now you just like simplify everything you can. And let me skip the middle steps of this if you don't mind, or I can show them if somebody asks. But I was gonna say, I already know that this right here that I'm circling with my mouse is a difference of squares type thing, where I will just get first thing squared minus second thing squared. So what I'm saying is this will just turn into x squared plus 9, because that the square root will cancel when I do this times this, and then minus 3 squared, so minus 9. And maybe I should have shown the middle steps because maybe some people are confused, but I'll show you what I'm talking about in a second. Let me just finish writing this step. Boom, boom, boom. All right, that's after the first step, after not showing my work. Had I shown my work, all I'm saying is when you have a plus b times a minus b, like two of the same things, just one's a plus and one's a minus, you know that you're just going to get a squared minus b squared. You FOIL that up. So that's why I'm saying let me not show my work. I already know what I'm going to get. Square root squared is just this. And then 3 squared is just a 9. Yes, good. Okay. Cool. All right. And then now we just simplify everything and we're done. So watch this. 9 minus 9 goes away. You get x squared over x squared times x squared plus 9 plus 3. The plus. Cool. And then you get x squared over itself. This is what should always happen when you do the conjugate. If you do it right, like you'll get a bunch of cancellations. And so at the end, there should be no 0 at the bottom. Boom. There's that. And then now there's no worries. If I plug in 0, I don't get a 0 on the bottom. I just get a 1 over square root of 0 squared plus 9 plus 3. And this will just turn out to be the square root of 9, which is 3. So 3 plus 3, so 1. Too fast or okay? Okay, that's what I figured from what I saw. Like you guys were already doing these on your homework, so it didn't seem to be a big issue. There you go. And then this one, that second one, hey, remind me later to change your attendance. I'm going to forget. So change it from absent to late or whatever. This one, oh, also they didn't change the schedule, Isaac. You're just having the normal schedule today. Yes. You're welcome. This one right here is the same thing. It's just the square root is on the bottom. So I don't know that it's worth doing, but we maybe just should get into 1.4. I think you've seen enough of these. Then let me skip this, but if you want to see it, I'll show you. I did it on my end, but I'll leave this one for you. Left, 4, 2. Oh, shoot. I leave that for you, and now let's do advanced limits. Okay, advanced limits has no intro or anything. These are all just limits that look like they might not exist, but they end up existing. And actually, a lot of these you saw already, like in 1.2 or whenever it was that we had 2 different graphs and one of the limits didn't exist, so we had to split it into left limit and right limit. That's just a bunch of those. But one of these, this one, A in particular, is pretty tricky. So I might... well, let's just do it. Let's just do them in order so we're not skipping around. Let's just do it right now. So watch this. I get F's graph and I get G's graph. And then this tells me find the limit of, in this particular case, F of G of X at 2. Okay, all right. So ideally, what would happen is both of these limits would exist. And then I just take the limit of G and take the limit of F at that result. But what happens is something weird. So watch this. Okay, I'm looking at just the inside right here. I take the limit of G, which is, I got to say something about that once I finish grading all your quizzes, because I saw a lot of notational mistakes on this, but I'll say that later, like at a later date. But just notice, oh, okay, I see G inside the function. I got to take that limit first and then take the limit of F at that result. So here's me taking the limit of at 2. It looks like the limit as G approaches, or sorry, as X approaches 2 of G is, you tell me what, here's 2. You think about it, think about it, think about it, think about it. What's the limit? Yeah, limit is 1, even though the function value is -1. We've talked about that before, but here's the limit. Okay, so the limit at equals 1. Cool. So far, nothing weird has happened. Now, if we take the limit of F at this result, limit as X goes to 1 of now F of X, you go to answer this question, and then you frown because, oh, shoot, that's the kind of the one place where that limit doesn't exist. So you're tempted to say that this limit doesn't exist, but back up a little bit because G approaches 1 in a very particular way. So G approaches 1, look at this, look at this. I come in from the left, it's coming in from numbers above 1. Okay, all right. Okay, I come in from the right, it's also coming in from numbers above 1. So what I'm saying is, in this very strange case, this is the trickiest one of all of them, I swear. In this very strange case, G is not just approaching 1 in any like arbitrary way. It's approaching from above on both sides. So what I'm saying is this limit is kind of like it's equal to 1 from above. Not that you'd ever say that as an answer, but since this is part of our next piece of work, since I need this result to get the actual result that I'm interested in, I'm putting that one from above there. I got a better way to explain it in a second. Just let me get this answer and then I'm done. So watch this. Limit as x goes to 1. Now from above, because both of these are coming in from numbers above 1. And I'm saying above, I just mean like from the right in this case. So if I come in from the right, that limit would be 1. Cool. So then this answer is 1. But it looks like, had I given you that problem, a lot of you guys may have said does not exist, but that's what it looks like. But the answer is actually 1. Okay, like I said, I have a better way of explaining it. Let me explain it in this way, and then we'll get through the other ones. The other ones are not as like tricky. But let me make some space because the people in the video need to be able to see what I'm about to write. So let me go like this, and then we'll get back to that. All right. All right, you don't have to write this, but just to convince you, because I remember this being a big problem every year when I teach this. But hopefully this will convince you. So, well, let me not call it. Let me make 2 separate tables. All right, so watch this. Remember the first thing I taught you this year was when we first learned limits. We took them by like plugging in 0.9 and then 0.99 and then 0.999 and then 0.999, etc. We were approaching like that numerically. If you think about it that way, it might be easier to understand what I just did about the coming in from above. So watch this. If I were to plug in numbers like 0.9 and 0.99, like approach it from this side, watch this. By going from this side, it looks like G is approaching, well, okay, like if I plug in, oh shoot, it was 1.9. Okay. 1.9, 1.99. 1.9, 1.99. Sorry, I thought it was approaching 1. We were actually approaching 2 originally. Limit as x goes to 2. My bad. Okay. But I'm approaching 2. If I plug in 0.9, here's me estimating that I get 1.1 or something. So then this would be 1.1 answer. If I plug in 1.99, you can see I get closer, but still numbers from above. So like, I don't know, 1.01. Let me make that up. If I come in from the other side and I plug in numbers like 2.01 and 2.1, same thing is going to happen because I'm coming in from above. So now watch this. Coming in from above, here's like 2.1. Okay, I get 1.1, like I said. 1.1. If I plug in 2.01, I'll get 1.01 as an output. You see what I'm saying? Yeah, all I'm saying is I'm looking at this graph. I'm plugging in numbers closer and closer to 2. I plug in a number close to 2 from below, I get not 1, but 1.1 maybe. And then I come in a little bit closer, I get 1.01. And then I come in a little bit closer, I get 1.0001. You see what I'm saying? Okay. I'm using those numbers, those outputs from G to get the input, like those are the inputs for F. So now to get the limit for F, I'm taking these numbers and I'm plugging them in. But notice how they're both coming in from above. It's like I'm taking in a 1.1 and I'm plugging it in and seeing what F does, and then a 1.01 and I'm seeing what F does. And from the other side, it's the same thing. So that's why I'm saying I can ignore the left limit. There it is. I can ignore this limit because these inputs, like G is the input for F, and those inputs are coming in from numbers bigger than 1. Okay. I don't know. To me, the tables were helpful, but now I'm looking around. and people were sad. So just okay. Just do what you can. Maybe try to convince yourself that what I'm saying is true. Notice that these are coming in from above. That's the only thing I'm saying. Yes.
If they were coming in from below, like say like the entire G thing upside down,
Yeah.
then it would be coming from the left. So then I think it would be instead of limit of f of x being 1, it would be -2.
Yeah, legendary. Yeah, right. If G looked like that, then look at I'm approaching 1 from numbers below 1. And so therefore, when I take this limit for f, it'd be coming in from the left because this number's smaller though. And so then the limit would be whatever, -2. Right. And you'll see one later where if it doesn't come in just from one side, like if it doesn't look like this or like this, if it just looks like a normal coming in from above on one side and below on the other side, then the limit would not be. But okay, now I know second period, save this one for last. Okay, the other ones, like I said, are not as intense. The other ones you've seen me do before. Like for example, this one limited that, or sorry, is x goes to 1 from f plus g of whatever. Your first hope would be, okay, do both of these limits exist, and then this would be an easy thing. But obviously, you look at the first one, limit is x, as x goes to 1 of f. Oh, shoot, that one doesn't exist. So you saw this one time before, but you may not remember that on 1.2 we did, if the limit doesn't exist, you just have to take the limit from the left and the limit from the right at 1. So watch this. Here's us doing that. Limit as x goes to 1 from the left of f plus g. Okay. Limit from the left of f. Hopefully you agree that this one, boop, 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 that's -2. Plus limit from the left of g of x minus 5. This x minus 5, before I over-explain, do you guys know what that's going to do? Like instead of you taking the limit at 1, guess where I'm going to take the limit? Yeah, 5 before, like 1 minus 5 is -4. Yeah, so I'm going to take the limit at -4, and I'm doing it from the left. So then that's this one, boop, 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 boop. That limit would be 1. Did I just lose someone? Question? Okay. Yeah, that one wasn't supposed to be a crazy leap. I'm taking the limit at 1, but this says x minus 5. Well, if x is going to 1, then x minus 5 is going to -4. Like 1 minus 5 is -4. Okay, cool. So -1 plus, or sorry, -2 plus 1 is -1. There's the left limit. Now I take the right limit, and if it's also -1, then I smile, and that's my answer. And if it's 18, then we'll talk about that in a sec. Limit x goes to 1 from the right of f plus g. Okay, cool. Here's us going to from the right. Boom, boom, boom. There's f's limit from the right is 1. Here's g's limit from the right. Again, I'm not going at 1. I'm going at -4. Coming in from the right, I get -2. Or 1 plus -2 if you like that better. And then 1 plus -2 is -1 again. So it works, you rejoice, and you say this answer should be what? Don't forget to answer the original question. Yeah, okay. Okay. I think it does happen on your homework that you get like -1 here and 2 here, in which case, what would you say for the original? All right, good job. Yeah, cool. All right, they start chilling, they start being this this level of difficulty. It starts with the hardest one. Okay, let's see if I can get all of these and the graph. Okay, well that's good enough. Here's another composition one. Oh, on the quiz, the ones I graded, A lot of people said G of F of whatever. They thought that was G times something. And so they gave me an answer of -10 when it should have been like 5 or something like that. To get multiplied it. But G of F of X, like if it's inside the parentheses, that's composition. If it wanted multiplication, it would look like a dot in between the two probably.
I just ate it too.
All right. Anyway, this one, same thing.
We both were in pre-calc.
Yes.
Let me take this limit. I hope it exists. Oh shoot! It's the limit is x goes to 1 of f of x. That's the first one I need. That does not exist, so I have to break it left and right. Okay. Oh shoot.
Not you.
Okay. So I have to break the whole thing into the left limit and into the right limit, which I'll show in a second. To take this limit, like if this orange writing had been the problem that I was given on my like worksheet, I would say, okay, to take this limit, I have to take F's limit first and then take G's limit at that result. You with me? You agree? Okay, so let's do that. And well, let's do it in orange so it all looks nice. Limit as x goes to 1 from the left of f of x equals, we've just talked about this, like this will show up a lot. That's this left one, -2. And then again, don't lose track of what you're doing. That's just the inputs limit. Now you take the limit at that result. So here's the limit for G at that result. Scroll down a tiny bit. Limit as x goes to -2 for G of x. I hope it exists. It does, okay. I made the key a while ago, so I was worried that G's limit would also require us to look at this from a particular side, but it does not. Now if I take the limit at -2 for G, here it is, boom, 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 it looks like it's approaching 2. Okay, cool. So there's my left limit in orange. This is like my final result for the left limit. Took the limit at the input, then the limit of the G at the result. And I got 2. Okay. Oh. It thought I said okay, Google. Okay. And now we do the other one in blue. Now the right limit in blue, limit as x goes to 1 from the right of G of f of x. Okay, if this had been the problem I was given, I would say, okay, I gotta take the F's limit first and then G's limit at the result. So F's limit, here it is in blue, coming in from the right, that would be 1. And now take the limit of G at that result. The limit of G at 1. It's hard to tell if I'm going too fast or too slow at this point. I don't want to bore you, but I don't want to overwhelm you. But the limit at 1 looks to be also 2. So final result for the right limit is 2. Final result for the left limit was also 2. So don't forget to answer the original question. This general limit means that it's also going to be 2. Final answer. Nice. Okay, and that's the story for the rest of these as well, except I think F might not exist. But I gotta go get my key for that. Nice, good job. All right, so are you guys all ahead of me, or are you waiting for me to keep going? Yeah. All right, watch this. D is in dog, same thing, except now it's G of F instead of F of G. It's the same thing, you guys. Limit for F at 3. You got to do that first. This one you rejoice because this one kind of exists. Like you can say what it's equal to. All right, limit as x goes to 3 of the f. You look at it, and it's going up forever. So this answer would be infinity. Nice. And now you take the limit of g at that result, which I don't know if you saw in pre-calculus. Cool. Okay, so limit as x goes to infinity of g of x. That just means what happens to g as x gets huge. So here's me checking as x gets bigger and bigger and bigger and bigger. What does g look like it's doing? Yeah, it's staying at -2. So this answer would be -2, meaning like the whole final answer would be -2. That one you didn't have to break into a left and right because you got a straight up answer out of the first limit. If one of the two had not existed, then maybe that take from the left or right. I think that folder pretty interesting.
Yeah.
Make sure you get some of this as well, man. Yes.
So I don't understand why f of x going to infinity means that you don't have to check both sides. Because like we were getting answers, like for C, we were getting answers for f also that existed, right?
But not right away. Like, yes. But it's kind of like I skipped a step because I saw if I had just taken the limit, normal limit, straight up limit. If I took that limit, I would get to this point and I'd be like, oh shoot, this limit does not exist in general. But if I take it from the left and from the right, then it does exist, which is what we were getting result. Other questions? Okay, all right, good job. All right, almost done, almost done. Number 5. Or letter E, I meant. Letter E you can handle. Then now there's nothing weird or new about it. Letter E I wanted you guys to do. And then letter F will not exist, but we'll do that one together. So here's like a minute and a half.
Like if one of these just gives you a 0, like this one, that means like it's just 0 for everything.
Oh yeah, well,
Because like I would have like this one is like weird because it's like it approaches from different sides, but no matter what it takes, it's still gonna be 0.
okay.
The other one is 0.
Yeah,
like
I
did
guess
that.
that's safe. The only time that's not safe is if you ever get like 0 times infinity, then there could be weird things that happen. That's indeterminate. But in this case,
it's like give x equals 0 and 3.
yeah. So then 1 times 3 or 7 times 3. Yeah, I get what you're saying. Yeah. Only time it's not safe would be infinity.
Okay.
But yes, I think that's right.
Yeah. Give x for it's approaching.
Yeah. Yeah. If it hadn't, then you wouldn't have. Because forward, yeah. Who was I just talking to?
Yeah,
Are you doing the homework? Or just I'm looking at the bill. Let me I don't know where I put my homework, but you might be right. I mean, it's on school with me to check. Yeah, we understand that.
Yes.
How many years have you guys been on?
Many times.
I love the guy.
Yeah, but I'm still stuck in that.
How many years have you got? You guys like.
I don't have it. I
What?
Yeah, three actually.
But I was having to look in my folder, but I don't think so.
Yeah. Have you guys tied with two yet?
All right, Keegan, give me a sec. Let me finish this and then. Okay, real fast, like I said, E is just like the other ones. You should have taken the limit at 4, and then you get to the F part. Oh shoot, 4 minus 3 is 1, so I have to take the limit at 1 of F, and that's the one that doesn't exist. 2 rats. Okay, so now that means I have to take it from the left and from the right. Take the one from the left, and you get -2 times -2 times G's limit at 4 from the left would be 0. So 0 on this side, and then do the same thing from the right, and you get 1 times 0. And so this one overall final answer is 0. Which I just checked like 2 or 3 people, and that's what they were getting. So, but if you did not get 0 or you don't see why I split it or whatever, let me know. Again, these are called tricky limits because this is what you have to do. Most of the time, if you get asked something like this, both of these limits will exist, and you just say F
Yeah.
times G equals whatever, like you did on. All right, and then last one is this guy right here. Where, first of all, you hope that both of these limits exist. So, first you take the limit of G, you get to G, and that limit exists. It's fine. It's not split. It's not one thing from the left and a different thing from the right. So this one is good. You get a limit of 2. Oh, -3, -3. Okay, I was gonna say, because I remember this not existing. Sorry. You take the limit at -3 for G. You get to this point, you get 1. Okay. That one, no worries so far. That one existed. And now you take the limit of F at that result. And the limit of F at 1, oh shoot, that one is split into left and right. So even if you split this into left and right, of course you're going to get different answers. So when you get to this point where it's the second one that doesn't exist, you're pretty safe to say it does not exist. So this limit does not equal DNE, but it just straight up DNE. Boom. The only thing you might have to check for is like, does it look like A where it's coming in from one particular side and I only care about one of the limits? But that's not the case because as you approach -3, you come into 1 from one side and you come in from 1 from the other side. So we're safe to say this one does not. All right, pretty tricky, but I have seen this on 1 question or 2 on like practice AP test. So if you have questions, let me know. Answer key for the homework is on Schoology.